So chemistry students, in this video I'm going to go over calorimetry, what that is and how it can be used. Alright, so before we can talk about calorimetry, let's talk about calories and weight and joules. So a calorie is a measure of heat or energy, and it is defined as the amount of heat that it takes to raise the temperature of 1 gram of water by 1 degree Celsius. That amount is equal to 4.184 joules. Okay, big C calories are actually kilocalories. So a big C calorie equals 1,000 regular calories. And the big C calories are the ones that you see on food labels. So 1 big C calorie is equal to 4,184 joules, or 4.184 kilojoules. So food calories are actually quite a bit of energy. Alright, so heat capacity and specific heat. Here's a couple of definitions for you. So heat capacity, usually represented with the variable uppercase C, is the amount of heat required to raise the temperature of an object by 1 degree Celsius. And then specific heat capacity, which is C with a subscript P, usually, at least on your reference table. A lot of times I'll just write C instead of writing CP. The amount of heat required to raise the temperature of 1 gram, that's the difference, of a substance by 1 degree Celsius. Now let's look at a little compare and contrast of these things, so because they're not the same thing. So heat capacity is a measure of the amount of heat or energy per the amount of temperature change that takes place, while specific heat is a measure of amount of heat per grams times the number of degrees of temperature change. So if you write that as an equation, heat capacity is heat divided by the change in temperature, while specific heat is heat divided by the mass of the substance times the change in the temperature. So heat capacity would be valid for a particular object, such as a calorimeter, which we're going to explore in a moment, and it's an extensive property. That means that the more of the object you have, the greater the heat capacity of the object is going to be. However, since specific heat takes into account the mass, which is the amount of the substance present, it is actually an intensive property. It's kind of like a rate at which heat is added to cause a temperature change. So it's an intensive property, and that means that it can be used to identify an unknown. Intensive properties don't vary regardless of the amount of a substance. Density, melting point, boiling point, specific heat, those are all intensive properties that you've probably seen on your reference table. And I'll pull up the reference table here for just a moment so we can take a look at that. So here's some properties that you can, whoa, too big. Okay, here's some properties that you can use to identify things. See the chart here at the bottom of page 1. So they give you specific heat, density, and melting point, and those are all intensive properties that can be used to identify substances. All right, so here's the specific heat equation. Let me draw attention to this too. So the calorimetry, or the heat capacity equation, it can be rearranged to Q equals heat capacity times change in temperature, and the specific heat equation can be rearranged to heat equals mass times specific heat times the change in the temperature. So in a bigger form here and with units listed. So heat is going to be measured in joules typically. Could be in calories too. Some problems might do that. Mass in grams, specific heat in joules per gram degree Celsius, or that could be in calories per gram degree Celsius, big or little c calories for that matter. So you just have to pay attention to units when you're working with really anything in science, but this in particular. And then temperature change in degrees Celsius, or it could be in Kelvin. Usually it'll be given in Celsius. All right, so here is the calorimeter that I've been referencing. And a calorimeter is just a device that can be used to measure heat transfer. Usually it'll be set up, especially in a lab setting, we'd put a couple of styrofoam cups together and then put some water in it, then maybe have something poking in to stir it a little bit, and a thermometer. Usually actually use the thermometer to stir, but you have to be careful so you don't break the thermometer. If you're using a temperature probe like we typically do, then you don't have a problem as long as you don't poke a hole through the bottom of the cup with the temperature probe. But anyways, it works on the principle that the heat gained by the calorimeter is lost from something else, or it could be the heat lost by the calorimeter is gained by something else. If the and basically you dump some object into this that's at a different temperature and let it equilibrate until the water and the object are at the same temperature. That recall that that's what happens in a heat transfer, is heat transfers until the temperature is the same for all the things involved in the heat transfer, and then the heat transfer stops, or at least in this case would slow down dramatically because the styrofoam does a pretty good job of insulating the system inside. All right, so Q lost equals negative Q gain. We'll use that again in a little while. All right, just to revisit this idea that this is a result of the law of conservation of energy. So if heat is lost in one place, it's gained somewhere else. All right, so let's take a look at how a calorimetry experiment might be carried out. So we might take an unknown metal. So this is a picture. It's not unknown right now to me or to you because I'm telling you what it is. But we could take this vial of magnesium, we could put it in a heat source and heat it up until it's 100 degrees or thereabouts. Then we could dump it in to this calorimeter and mix it around with the water in there. And what would happen is the heat from the metal, some of it would be absorbed by the water. So the temperature of the metal would go down and the temperature of the water would go up until they reached the same equilibrium temperature. And then we could calculate perhaps the specific heat of the unknown metal. So we're going to do a few examples of this. I'm actually going to come back in the next video, so you can just pause it, write the questions down, and that should be the answer. And then example 2, and that should be the answer. And example 3, and this should be the answer. So we'll come back to those, and I'll work this out in the next video. So thanks for watching, and I'll see you in a moment.